I have the honor to kind of conclude the day with a roundup or a tour through CityEngine 2019. So my name is Simon. I'm working here in Zurich in the R&D center. I'm a software developer there. And basically working all over the place in CityEngine. It's been 10 years now already. So I'd like to take you through a tour of CityEngine and what's new in 2019. Kind of will start on the lower left there with urban, going through CGA, GLTF, physical-based rendering, the SDK, and then some licensing details which have changed, and conclude with some very pretty pictures from my colleague of the VR team, which work with the Unreal Engine and virtual reality applications. So as Lisa has mentioned, and I would like to connect to her talk here, CityEngine has now this integration with ArcGIS Urban. So you can get project plans, you can synchronize. So therefore, one of the most visible changes, as she already demoed, is this new ArcGIS Urban menu item. If you're not interested in Urban at all, you can also hide it in the preferences. Sorry. So now, let's be serious here. So in Urban, you have this nice dialog where you can configure the plausible building rule, as Lisa explained. And I would like to use this as a kind of a segue into CityEngine, because behind this is actually a CityEngine rule package, so CGA rules. And as Lisa mentioned, there is this CityEngine module in Urban, which is actually a CityEngine SDK compiled for the web. So as a software engineer, this is quite exciting stuff for me. We actually managed to compile the procedural runtime in CityEngine using WebAssembly and connect it together with rule packages and put it all into Urban. So you actually have, and I like this very much, you actually have running CityEngine in the web browser. And this was a pretty nice step to achieve. We were actually not sure in the beginning if this works. And this is really cool. So now we were talking about CGA. And so let's look at some new things in CGA. So I won't go through all the new things here, but I want to call out maybe two of the new operations. So one of them is rectify. This has actually been motivated also by the Urban rule package. It is a kind of an advanced algorithm which tries to find or align edges of your shape to your shape scope. So if you have like a crooked data or noisy data from survey data or badly digitized data, this little tool can help you clean this up. Another new extension is the setback per edge. So to date, we only had setback like uniform setbacks. And now with setback per edge, you can actually control your setbacks on a shape per edge. So you have this argument here. We just use a random in this example. It will now be evaluated for each edge. So you can pass in functions in there and have them react on the different edges of your shape. Actually, let's stay quickly here. There's also a few others. Just want to briefly mention setback to area. You can control the size of your remainder shape. It can solve some situation. And also reset geometry if you want to reset your shape back to the cube after you have maybe inserted some assets and you don't want to have them in your final model. There's some new functions as well. There's the read text file function, which can be quite handy to read in text files or comma-separated value files into attributes. We actually use that in our new plans library, which I will describe later. And there's also, for example, a new comp function. So this is not the comp operation. This is the comp function, which basically gives you back a list of attribute values in a similar manner as the comp operation works, but it will not produce geometry at this stage. And last but not least, small change to align scope to axis. You can also work with the local object coordinate system. So that's this part. And now, before I go into our new GLTF importer-exporter workflow, I quickly would like to maybe recap what Roman already alluded to, is the physically based rendering, which is now kind of a loosely defined industry standard. So I just want to briefly mention the different components which such systems usually use. Roman also already talked about the albedo, just basically the color, constant or map-driven. Then we have the kind of reflectivity or metalness, as it's called. So people usually go from rubber, 0, to metal, 1. It's also an indication of how much they reflect the rays or the light. They have a kind of a separate axis or orthogonal axis to that is the roughness. That's kind of a new thing, not supported by CityEngine before. So you have rough surfaces, which are not very shiny, and you have, on the other scale, glossy surfaces, which kind of mirror-like reflect everything. So you can have shiny plastic, dull plastic, shiny metal, dull metal. These are these two kind of dimensions. Then a bit more advanced, there's of course transparency-based effects, like refraction also. So you see that the light is actually colored through the glass when it hits the floor. This is one of a very nice effect. It's also sometimes called color bleeding, when the rays bounce off a colored wall to a white surface. And then at the end, we also have the so-called Fresnel reflections. So you notice that in the middle of this ball, there's no reflection, but at the grazing angles on the outside, there is a reflection. So this is also an effect which is usually included into in PBR systems. So with all these kind of material aspects, let's take a look what we did in CityEngine. We basically added new CGA material attributes. We now have support for this roughness I mentioned, the metallic aspect. Then the two ones I didn't really introduce, it's the emissive. It's just if an object has itself a glow or a color. And the occlusion is kind of an acceleration technique to pre-compute self-shadowing. So this gives a very nice effect. It's sometimes also called ambient occlusion. And in some systems, you like to pre-compute this because it can be quite expensive to render, especially if you have no ray tracing. And they are then used in combination with the existing attributes as well we already had for quite some time. So this now brings me over to GLTF, which supports all these new capabilities. So GLTF, we look at it a bit like it's the new OBJ, but with much more features, much more modern. So one of the biggest features is, of course, the PBR support, but it's also supporting instancing. It's a nice standard, clearly defined standards with a mechanism for vendor-specific extensions. It's backed by the same kind of foundation who also deals with Collada and OpenGL. And you see these effects I mentioned before in terms of materials. When you look at this example here, it's one of their stock samples rendered in Unreal. You see the emissive, kind of this glowing display here. You see the rubber holder and the metallic-like body of the can or of the bottle. So that's pretty nice way to represent these models. Just a quick aside, GLTF usually comes in two flavors. You can have like a multi-file version where the actual asset is described in JSON, text file. You have a compact binary for the geometry and your usual text files. What we make use of most of the times is a single file solution where you have all of these in one handy little file, or big file sometimes, and you can neatly distribute them. And it also supports instancing, by the way. I didn't mention that. So to summarize this PBR support in conjunction with the GLTF import-export, we now have this PBR-capable GLTF importer in CityEngine, also the exporter, but we also have Unreal and Alembic, which can transport those new material properties into, of course, Unreal and also other tools who read Alembic, like Houdini, Maya, or Katana. And maybe just a small note for you, for the advanced CGA coders in the audience. We now set the material shader to a new value when we read GLTFs. So then you already know that you have PBR attributes and you can work with them. Fortunately, the viewport does not yet show these attributes. This is ongoing discussions how we do this best and what's actually needed. So now we have the GLTF features. We can also build libraries. And so what we did kind of across the platform, so not only CityEngine, also the ArcGIS JavaScript API, ArcGIS Pro, we now all use a same library of assets. So here, for example, is a tram model. And you also see it on the JavaScript API reference pages listed. So now you can really work in CityEngine with these assets. You can publish them to the scene viewer. There you have the same assets. And they will all match because they have all been designed and curated kind of in one set. So that they nicely work together. And there's also a new plant library in here. You see this vegetation. I can actually go one slide further, see it a bit better. So CityEngine has now this kind of ESRI.lib, which is the name of our built-in asset library. It has a manager for that, so we can now asynchronously update you with new assets and new categories of assets. And so we're not tied to the CityEngine releases by themselves. So now let's switch gears a bit. I would now like to move into the area of the CityEngine SDK and what you can do with it and what this means for licensing and pipeline integrations. So my background is actually in this area, in the VFX and games procedural modeling. And this is kind of, I guess all of you kind of recognize your work with CityEngine. You import maps and assets. You do your terrain, street network modeling stuff. You work on the rules. And you export them to some tool, being it a renderer or a JS database. Now, one of the issues with that is that you often have to do this loop, which is annoying sometimes when you have large scenes. CityEngine work in blue, and then some more work in other tool, typically an import and wrangling attributes to make the shaders work in this other tool. And with the CityEngine SDK, we would like to enable users to be able to defer the generation of models, obviously, in downstream tools. So myself, I did, and Matthias, actually, we worked on a tool called Palladio, which Romain already alluded to. And I think I mentioned it last year briefly. And we kind of tried this out in Houdini. Houdini is also a very old 3D modeling and animation tool, which has a strong procedural character. And the main reason we did that is to enable novel CGA workflows. So one of the nice things, for example, in Houdini is you can chain multiple rules behind after each other. So you can generate a model and feed that into a next rule, which is not easily done in CityEngine. And all you need is Houdini, and you're good to go. The rest is on GitHub, basically. So what's actually new in Palladio since last year for those who used it? And now I apologize, this is now very Houdini-specific slang. For example, the first one. We now support these Houdini digital assets, which is a very neat thing to put a whole city in one package. You can now create one file. You have the Palladio plugin inside. You have the CityEngine rule package inside and any other Houdini nodes. So you can basically take a Houdini scene. I'll show you an example afterwards. Drag and drop this package in there, and you have a CityEngine city ready to go. We also added support for some more traditional features of CityEngine, like the intershape occlusion. So these are two initial shapes, and the red part is obviously where they collide. So you can now query that. And we did also some work on the materials to have a better support for out-of-the-box material attributes. For the upcoming release, we prepared a number of digital assets for you to use. We also prepared some examples and the actual Palladio code itself. So this is all public. If you feel curious, go to GitHub and take a look. And once CityEngine 2019 is out, we will all release that in one go. A few examples. This is Houdini. This is a rule set created by Matthias Bühler. This is the favela city. We already showcased that in some Unreal demos over the years. And just to illustrate the basic workflow of Palladio, here we create a grid of parcels, like a chess board. We add a random terrain, have a bit of undulation. We align each parcel onto that new terrain. And this node here creates the whole city and applies the materials. So it's a pretty neat workflow. And just to a technical deep dive here to illustrate that, this is Palladio actually. We assign a rule. That's like in the CityEngine inspector. You assign a rule and you say which start rule and which rule file. And here you basically hit the generate button. It's just Houdini who does it for you. And for the technical inclined, you see here, there's a favela.rpk, that's the rule package, which is hidden inside this digital asset. So this is quite exciting tech, and it allows for many workflows. And a final sneak peek is this little demo, Encore Tom, created by Matthias as well. We used CityEngine to lay out the structure, and then we used Houdini to grow veins and weather the stones and add grass. This is all done in one package, and there was no import-export involved except creating the rule packages, obviously. Okay, so enough about Houdini geekery. Let's look at some of the license changes. We want to make working with the CityEngine SDK much easier. And therefore, we would like to announce that you can now use the SDK without any CityEngine license, technically. So there's no more license checks when you run it, which makes deployment much more easier. With the caveat, it's free for non-commercial use and in-house development. CityEngine itself, I just heard, will in the US be available for $100 for non-commercial use. And it will also be included in the ArcGIS for personal use and the ArcGIS for student use. And I think I forgot to say that it's also included in the urban packages. Then what did we change in a CityEngine virtual reality experience, so based on the Unreal Engine? On the CityEngine side, we added direct terrain export. So I think in the previous version, you had to manually import the height map and create the Unreal Landscape node. This is now directly integrated in the Datasmith exporter. And we also added support for metadata. This means CGA reports and object attributes from CityEngine. This is really nice to build custom widgets in Unreal, so you can create pop-up widgets on buildings with metadata really easily, using the Unreal Blueprint system, for example. Then on the Unreal side, the XR team worked on support for Oculus Rift. Before, I think there was only the HTC Vive officially supported. We worked on the better daylight support, so you can have this kind of apocalyptic sunsets. And also we worked on a sketch style rendering and a better documentation. So here is one of the examples which kind of a sketch NPR style render mode and a really nice examples done in a bit more realistic fashion. This is I think Boston showcase where they worked, or the requirement was to have much more greenery. And so we really pushed the system with a lot of building tree geometry, vegetation geometry. And I think it was not, this is not really a real-time capture, but near it. So it's not sure. I guess it's about 5 frames or 10 frames per second, or somewhere over there. Here's another example, a bit more movement. So with Unreal, it's now really easy to create these kind of visualizations in much less time than before. So there's no hours and days of ray tracing. You can really have nice PBR-like experiences in less time. So I'd like to summarize. We have this new integration with ArcGIS Urban. We added GLTF support and PBR support, kind of a first generation PBR support. We work on CityEngine plugins for other applications. We're doing actually the same also for Maya. I demonstrated for Houdini at this point. We changed the licensing. We also added a named user license, so you don't need to deal with the node-locked or license server anymore. You can use your ArcGIS online accounts as well. And we did all these changes to the VR experience, Terrain export, and Oculus Rift, for example. A few words to road ahead, or maybe before that, of course, we literally had hundreds or multiple hundreds of bug fixes and changes to CityEngine 2019, so I cannot list everything. Make sure to read the release notes and the what's new once they're out. I'm sure there's something for everybody. And before I go, a few things, what we are looking at in the future. Of course, as Lisa mentioned, the ArcGIS Urban integration, more Unreal support, more urban design features. We're also looking currently into a Python API for PRT directly. That could be very interesting to rapidly prototype applications. I'm personally also interested, if you guys are interested in the USD, Universal Scene Description support, kind of the VFX technology. And we do some funny experiments with machine learning or global optimization. So here's a little early stage demo where we try to maximize or find global optimizations for certain report values. In this case, you would like to find the max value for, I think it's a maximum number of spaces or places where we could put trees or greenery. So we're now playing with different global optimization algorithms. Some funky optimize button. Now the algorithm tries to find the best model, or the optimal model, to put as many trees as it can. And last but not least, something for urban as well. We're trying to turn the CityEngine kind of virtual reality experience into a also AR experience, and actually make it directly available from the ArcGIS Urban directly. So you can directly publish from ArcGIS Urban to Unreal into a XR application or experience. And with this, I'm already done. Thank you.
Thank you for your interesting news. Do you have any questions?
So you mentioned about the GLTF, that it exports to Unreal Engine as PBR materials.
So
my question is that if in CityEngine you have a material that is not a PBR, for instance, it already has a peculiar map, when you send it through GLTF to Unreal Engine, it changes the values somehow?
So for Unreal Engine, it's best to use the DataSmith exporter, not the GLTF exporter. And in the DataSmith exporter, we actually decided to not do any smarts. So you set, in this release at least, you set the PBR values, and they will be passed one-to-one to Unreal. For the next release, we're actually looking into having a bit of smarts, so you have old style materials that they are kind of converted into PBR materials for Unreal. Yeah. Yes?
I saw those people walking on the sidewalks. That was pretty cool.
In the Unreal movie, I guess.
Yes. Is there anything you're thinking of, like supporting more of those, like traffic-like functions in CityEngine? Like a traffic model with lights, changing lights and pedestrians crossing the screen.
I think at this point we consider CityEngine still the kind of the static modeling application. We could certainly add attributes to drive simulations afterwards in Unreal. So I guess we will keep time out of CityEngine for now. Yeah.
We're actually working on workflows that you want to figure out what are the best tools in Unreal for simulation and animation, and then working on workflows how you can control this on CityEngine. So, for example, here you have sidewalks. So that all these guys would actually. One of the goals here was that they were all on sidewalks, and we almost hit it. So, but here you see, but these workflows kind of have them in a scalable way, in an easy to use way, so that but we're really working closely with the Epic guys and kind of making up the city animation piece. So this is something we work on, and when you're interested, write us an email. We also had stuff with traffic. I'm not sure if you saw that at the last UC. There we had the cars in the CityEngine VR scene, and then, but yeah, it had some glitches. So, for example, you could catch the car and throw it away, which was weird. So yeah, we're still working on this.
It's an interesting problem. We already worked on that a number of years ago with together with the Massive software tool. There we also had this problem of how to kind of populate their data structure. Where can cars drive? Where can people walk? And so we're now trying to figure that out for Unreal as well. Because, also, of course, they have a complete new way of describing these things. So, yeah.
Well, two questions, a small one and a bigger one. The little one, you were a bit vague on PBR implementation in the CityEngine viewport. Is that in the pipeline or no?
There's no decision yet, to be very honest. So we are trying to figure out, as you can mention or imagine, a full ray tracer in the viewport is quite a feat, and we also would have to use proper lighting, image-based lighting, so that all these nice PBR materials make sense. And so we're really trying to figure out what we want to do. It's going to be no easy thing.
Here, what I also can say is basically that the whole ArcGIS platform is moving towards physically based rendering. So it means we're working on several tools, and one of them is, for example, the JavaScript API is going there also. So it means things on the Esri platform will look better, and so, for example, if these things look better, then also things in Urban, for example, look better. And then with CityEngine you create the content, and with Urban, like Lisa showed, it's one click, and then you see it in its all shininess. So it means for now we see CityEngine really as the design tool, the urban design tool, and not so much the visualizer. I know you said you want to stay in one tool, and we hear you, and yeah, we want that too. But yeah, there are sometimes other formats like web or VR, and for sure we will not make CityEngine VR application, for example.
So a bigger
Sure.
question, I mean, in the CAD industry, integration with various types of environmental simulation plugins is really big and developing. Is that a path you're even contemplating going down?
I guess at this point we see us in the form of the SDK, in the form of procedural runtime, being integrated into other tools and not necessarily integrating other tools into CityEngine. So that's currently the strategy. Yeah.
I recently read about placeholders in CityEngine. Does it have to do anything with the metadata for VR? You mentioned before about the CGA reports.
Placeholders.
Yeah, like creating somehow a placeholder in CGA for validation to further upload in Unreal Engine.
Yeah, you're probably referring to a technique to kind of put proxy objects in CityEngine and then replace, for example, a tree, and then replace it with, for example, a speed tree object in Unreal.
This is exactly the new tutorial. So the new tutorial in Unreal is exactly that. Yes, these workflows.
I think this is actually part of the tutorial. This is the illustration to the tutorial.
Any more questions? No? Okay. Thank you so
Thank you.
much for your presentation.